See fundamentals today. Okay, so alternating current, like you know already, right? AC current and DC current, DC and AC. So difference between AC and DC. One, it's periodically change direction. Yeah. Alternating current means AC is the one which change the direction.
Yeah, so we learned it in 10th. We had the
Yeah.
difference. It also came in boards, I guess. Yeah.
Yeah, it came. And DC is the current which may or may not change the magnitude,
It doesn't
but
change the
and
direction.
does not change direction. Magnitude may differ, but direction never change. See, magnitude in the sense just value. Value obviously it can change, but in AC only direction is important here. Direction changes. In DC doesn't change. That's what the main difference here. Now it changes periodically. That means it can go from 0 to maximum value. And here DC, it remains constant. Whatever value has been made, it will be constant throughout. So it increase from 0 to maximum value in the direction and decrease to 0. So like this, it goes maximum and goes back to 0. And again goes back in negative direction and again come back to 0.
While the DC current is like,
Doesn't do that.
yeah, it's constant.
It remains constant. Okay. So that is what alternating current. Now this curve we will denote as a sine curve. If you know, like a sine. Wait, my pen is not working. Yeah. What is sine zero value? Sine zero. Cos zero. Tell me these two values. Sine zero is 1 or 0 or infinite. Can you hear me right?
Yes, sir.
Yeah. So tell me, what is it? What is sine zero value?
0.
Sine zero is 0 and cos zero?
Infinite or not defined.
1.
Cos zero is 1.
1.
Okay. So that means what? If I take both values of zeros, sine zero, it starts from 0. So this is the 1 and cos starts from here. Cos starts from here. Let me change color. Yeah. Cos starts from here. And sine starts from here. 0 is the starting point. So cos is already leading here. So that this whatever we are drawing generally, that is called as sine curve. Sine curve. And this is called cos curve. Cos curve. These two things you need to remember. We will use so many times. Okay. So alternating current at any instant equals to I naught sine omega t. Now, omega means 2 pi omega equals to 2 pi frequency. 2 pi means 360. 360. One, it goes from here to here, it makes 360 degree. 0, or we can say here 2 pi. This is 180 pi. This is pi by 2. This is 90 degree. 90 degree sine 90 is, see, sine 0 is 0. Sine 90, 1. Sine 180 again 0. Sine, what is the next? 270 is -1. Sine 360 is 0. See, that is what we are making here. 0, 1, 0, -1, 0. -1, 0, 0, 1. Got it?
Yes, I got it.
So omega is 2 pi f. Or another way of writing is 2 pi by t. So because f equals to 1 by t. So omega is 2 pi f or 2 pi by t. This thing also we need to remember. We will use omega many times here. Okay. I not sine omega t. So this is what sine curve we are talking about. So alternating EMF at any instance, that is E equals to E naught sine omega t. EMF means electromotive force. And electromotive force means a force which is like required. Like if I take this, we have discussed in 10th standard also EMF little. So if this is the connection and this is the battery connected, so this is the force which makes them, okay, yes, there is a requirement here, and it will, like, there should be some way of moving the electron here. So that force makes like a requirement here to move electron or whatever particles it requires here. So electromotive force, movement.
So it means that the energy supplied by a source
Ener-
of current, right?
exactly. It's like energy.
So generator, batteries and cells are an example of EMF, isn't it?
Maybe, yeah, we can say that. Are like they work like similar way.
No, so because those are the examples we had in 10th.
Sorry, say again.
So those were the examples we had for EMF in 10th class.
Yeah.
Cell, battery and generator.
Yes, those were the examples, correct. But see, actually, EMF is just a force. Like it is not. We cannot see these things. Okay, this EMF we cannot see. We can
It's
see
a
battery. We can see generator.
mechanism. It's a working mechanism, kind
Yeah.
of.
Yes. Yes. Okay. So yeah, even I wrote this one. So this is your one cycle. Is it drawn here? This is one cycle. So this one cycle means 360. So here T, if I take one time period T here, this is a half time period. This is T0. At T0, the sine curve was 0. At t equals to t, it becomes one cycle. So this blue color which I have shaded, this is one cycle. One cycle or one time period or one oscillation or whatever we can say. And here I naught and E naught are the peak values. Peak value means a maximum value which is possible by the current element or this volt EMF element.
That which is corona points.
Yeah, sure.
More.
So can you send the screen in the group? Because there's something wrong with my device. I can't take screenshots.
Yeah, sure. Sorry. What did you ask?
So can you send these notes in the group? Because
Yeah,
there's
sure.
something wrong with my device. I can't take screenshots.
Sure, I'll send it. I'll upload all the notes which we have finished chapters by tomorrow or day after tomorrow.
Okay, so
Done, sir.
Done? Okay. Okay, so we will go with some average and RMS value. First, let's see average. Average means you already know average means like taking the mean value of those things. So average value of AC over the full cycle. See, average value of AC over the full cycle. So these are equal and opposite. If you observe here, they are equal and opposite. So obviously, if I take average of those, it will become 0. Average of full cycle is 0. But average of half cycle is 2I naught by pi. Like pi by 2. Same way for EMF, it is 2E naught by pi. Let's go for next. RMS value or root mean square value. So in this one, so direct current which is produce the same heating effect in the given resistor in a given time, which is as produced by the AC flowing. So we are just comparing whatever heat produced by the direct current It produces a direct current of that resistor, which is like similar to the AC flowing through that same resistor. So this is what RMS value in short it is effective value or mean value, root mean value. So that is IRMS equals to I naught by root 2 and ERMS equals to E naught by root 2. E naught is the peak value. IRMS is the mean square value. Now in question, there will be so much confusion between mean value and average value and all that, because see in question they will give 20 ampere or will say 220 voltage. So what will take? Either we are going to take RMS value or mean value. Sorry, yeah, peak value. So one thing fix in mind, in whatever question given, until and unless they mention, we will take that as RMS value only. Okay? Until and unless they mention that peak value of this thing or max value of this thing or something, some other way, by using some other words, if they mention something, till then we will assume it as a RMS value of whatever given, let it be current or voltage. Sorry. Yeah, this thing we need to fix. Until mention. Okay. Next. Time period. Time taken by AC to go through one cycle of change. See, meaning is same, just words different. Time taken to complete one cycle. That's it. Simple words. That is also equals to 1 by frequency, or as we wrote before also, omega equals to 2 pi by t. So t equals to 2 pi by omega. Then shall we go next? Okay. I hope done. Chalo, next. Phase diagram or phase of first let's understand about phase, then we'll go for phase diagram. Phase means like a property of motion, wave motion, how it is moving. Okay. So like position of particle also at any particular instant. So if I draw that phase at this place, if I talk about this particle was here at this time, this particle was here, it went here at this time, and it reached here at this time. So it shows a particular time, at particular instant or particular time, where was the direction of the motion, what was the direction of motion, or what was the position of the particle. So it is measure either by angle which the particle makes with the mean position or by fraction of time period. Means ratio of time period. That is your phase. Next, we'll go for phase angle. I'm just going with some basic theories. Then we'll go for some good things.
So what's the next chapter you're gonna start?
Magnetism.
So could we start with wave theory? Wave optics?
We haven't completed wave.
No, sir, we haven't completed wave optics.
Oh shit, then I should have done this before. Oh, because, okay, fine. After this, we'll do wave optics. So most of the 12 chapters are over. Only one semiconductor and magnetism left. Wave optics is small only, so it won't take much time. So do you know AC fundamentals? Samhita,
Yes, sir.
have you practiced AC fundamentals?
No, sir, we didn't start AC fundamentals.
Oh,
We
this is
just
also
started magnetism. Basically.
it is also important. This carries like some with the EMI. This carries like 1 or 2 questions, minimum 2 questions. So be ready for January exams only. Okay. I want you to give Jan exam.
Yes, sir, I'll try.
You to give best.
Yes, sir.
Okay. Chalo, ठीक है. See, like once I finish this chapter, then all this 11th chapter will be over. Then we can do like all like random one worksheets. We will make it and we'll solve all the questions randomly. All the questions. Okay. We want like for that I need 2 months so that we can have 2 months solid practice. Which I'm planning. If I finish by November, we can do some solid practice. Then for 20-25 people have some time. We'll practice those things again. Okay, fine. Now let's go for phase angle. So now phase angle means angle associated with some motion where it was like similar type. So as we discussed before, it is sine curve or cosine curve. Sine curve starts from this position and cosine starts from here. So this means what? This portion of the cosine curve is already leading. Cosine is already leading. When sine 0 was at 0, that time cosine 0 was at 1. It was already leading. So cosine curves leads sine curve. So lead in the sense ahead. This portion we'll see later. lead and lag means some portion is ahead and lag means behind. Not this one. Yeah. Yeah, these are important things. Resistance offered by element to AC. So there are three ways of giving resistors. Okay, like three types. That is one, inductor, resistor, and capacitor. So all this inductor means coil. All these coils have resistor in it. And capacitor, you already know, right? Those are also having some resistor in it. So all these three materials have resistor in it, resistance in it. So resistance in different type, it is inductor, resistor, and capacitor. So unit of inductor is Henry, unit of resistor is ohm, unit of capacitor is Faraday. F, farad. So inductor, it is like a type of resistor which is used in coil, and capacitor stores energy. There's a work. And resistor, what? Resistor, it's regulate current flow. That thing we already know, right? Resistors already, we know that it's just regulate current. So resistance, this all I see, this all are resistance, type of resistance now. This thing we are going to convert. Inductor and capacitor, we cannot see. Whenever we are using some resistive values, if you remember, whenever we are doing some resistance and capacitor numerical, we will eliminate this one. We will not consider this one and we will solve it. Or we'll open the circuit. Or whenever we are calculating for capacitor, we will eliminate this one. So either way we have to use. We cannot use together. So for using this together, we have one more term that is called reactance. Reactance means hindrance or same way resistance offered by inductance and capacitance or both. So if it is inductance, it is called inductive reactance. If it is capacitance, it is called capacitive reactance. Those things we will study in the next classes. Maybe tomorrow we'll have class. I'll post in the morning according to the timing. We'll see. Okay. Yeah, shall we have it morning itself? 11 o'clock? 11 to 12 we can have, because I missed 2 classes, so we can have it some 11
Yes.
to 12.
Okay, sir.
I have to put reminder. Yes. Tomorrow I don't have any class except one. Yeah, except one I don't have any class.
Sir, could you show the definition once?
Yeah, sorry, yeah. This thing tomorrow we are going to discuss itself. This one only.
The reactance thing?
Yeah, both impedance also. I didn't discuss impedance. We'll start with impedance here.
Okay, we're gonna discuss. Okay.
Yeah, I just gave some little idea about this. So this, from here we will discuss. Okay then, see you tomorrow morning 11 o'clock.
Thank you, sir.
Okay, bye-bye. You might have another class. Join it.